Um, so I wanted to talk a little bit more about this last problem the first on guided practice 12.03 that I had said I wanted you to think a little bit about and work a little bit on your own. I want to give you a little bit more of a hint of how to go, especially with this problem about the hexagonal prism. And part of what I wanted to talk about was hexagons and some interesting properties of regular hexagons. So here's a regular hexagon, which means that, well, it's got 6 congruent sides. Let me try to make it a little bit flatter, and it might look a little bit better. Okay, it's still a little bit not perfect, but it's supposed to have 6 congruent sides. And there are some very interesting properties of such hexagons. For example, the length of the side turns out to be equal to the length of the radius. Okay, so regardless of what length the side of the hexagon is, if this is the center, and this is a line segment joining the center to a vertex, and this is a line segment joining the center to the vertex, interestingly, this is an equilateral triangle. And so is this. Because, of course, all radii of the hexagon are going to be equal, so this is also S, and this is also S as well. So we have another equilateral triangle, and yet another equilateral triangle, too. And so here as well, and here as well. So a regular hexagon is actually made up of 1, 2, 3, 4, 5, 6 equilateral triangles. And the side of each of those equilateral triangles is the same side length as the regular hexagon. So that means that the area of a regular hexagon has got to be 6 times the area of an equilateral triangle. So the area of a regular hexagon, okay, is equal to 6 times the area of an equilateral triangle, which you may remember is s squared, the square root of 3 over 4. Okay, so if s is the side of a regular hexagon, then the area of that hexagon, and I'll kind of draw it like with a little hexagon there, the area of the hexagon is, well, let's do the sum of the multiplication. 6 and 4 cancels out to be 3 and 2. So it turns out to be 3 times s squared, the square root of 3 over 2. That turns out to be the area of a regular hexagon. And it follows directly from the area of an equilateral triangle. That means if we go back to this problem here, and we see that the radius of the hexagon, which is the top face of the polyhedron over here, has a radius of 4. It also means its side length is 4 too. So let's draw, and that of course is true not just for the top base, but the bottom base as well. So let's go ahead and draw that. So we have regular hexagons on top and bottom of this hexagonal prism, and we've got the radius is 4, which means the side of each of the hexagons is also 4, which means now we can use the hexagon area formula, which is the area of a hexagon is equal to 3s squared square root of 3 over 2, and just plug in s equals 4. If we do that, we get the area of the hexagon in this problem is 3 times, well, s is 4, so 4 squared, the square root of 3 over 2. And we know how to evaluate this. We evaluate it by, for the moment, ignoring the square root of 3, carrying out 4 squared being 16. 16 times 3 is 48, so we have 48 square root of 3 over 2, which is 24 square root of 3. So the area of each of the hexagons is 24 square root of 3. And that turns out to be important because as we go along and we do this problem, we've got to come up with the perimeter, the area of the base, etc. Let's actually go through this a little bit then. So the perimeter is Well, each side is 4. The radius is 4, and the radius is equal to the sides in a hexagon. So 6 times 4 is 24. So the perimeter is 24. What is the area of the base? We just did that. It's 24 square root of 3. So the area of the base is 24 square root of 3. We go right down to the surface area. Well, the surface area, we remember, is 2 times the area of the base plus the perimeter times the height. Well, the height, we look back, is 9 yards. So the height is 9. The area of the base is 24 square root of 3. So we have 2 times 24 square root of 3 plus the perimeter of 24 times the height of 9. I'm going to get my trusty calculator out here. This comes out to be 48 square root of 3 plus 24 times 9 being 216. So that is our answer. 48 square root of 3 plus 216 square yards. And the volume, remember our volume formula is area of base times height. And in this case, the area of the base again is 24 square root of 3. And the height is 9. So once again, we get 216 times the square root of 3 cubic yards. Okay, we can write it like that. This is 216 times square root of 3 cubic yards. Well, I hope that helps a little bit with how to do that problem.